The radio spectrum, ITU frequency bands, VLF, LF, MF, HF, VHF, UHF. The radio spectrum is an important part of the much larger electromagnetic spectrum, which includes not only radio waves, but also light, infrared and ultraviolet radiation and some other forms of radiation as well. Understanding about the electromagnetic spectrum and what the different forms of radiation are and how they respond helps give clues about the different forms of radiation behave. Similarly, understanding the radio spectrum and the different wavelengths and frequencies is key to understanding the properties of signals at different points in the spectrum. Differing wavelengths and frequencies mean that the signals have different properties and can be used in different ways: long-distance radio communication, point-to-point radio communication, radio links that are more secure because the signals do not travel so far, satellite communications links and many more. Different frequencies and sections of the spectrum may be more appropriate for one form of radio application than another. Names like LF, MF, HF, VHF and UHF, EHF, etc. represent portions of the radio spectrum or radio frequency spectrum and will be familiar to most people. ITU frequency bands designations. The International Telecommunications Union, ITU, is a global organization regulating the use of the radio spectrum. In order to be able to easily refer to different portions of the radio spectrum, the ITU split the radio frequency spectrum into 12 different bands which are numbered 1 to 12, but also given names. The borders for the different ITU frequency bands are at the different decades. For the wavelengths of the signals, the band designations were drawn up when wavelength was the method for measuring the position of the signal in the spectrum. As frequency is used these days rather than wavelength, the borders for the bands occur at points equal to 1x10n. For example, the HF portion of the spectrum extends from 100 meters to 10 meters and this corresponds to 3 to 30 MHz. These bands are defined within the ITU radio regulations. Article 2, Provision No. 2.1. Originally there were only 9 bands, but as the extent of usage and future usage of the radio spectrum has increased, there are now 12 bands. Band name. Abbreviation. ITU band number. Frequency. Wavelength. Extremely low frequency. ELF. 1. 3 to 30 Hz. 1 lakh to 10,000 km. Super low frequency. SLF. 2. 30 to 300 Hz. 10,000 to 1,000 km. Ultra low frequency. ULF. 3. 300 to 3,000 Hz. 1,000 to 100 km. Very low frequency. VLF. 4. 3 to 30 kHz. 100 to 10 km. Low frequency. LF. 5. 30 to 300 kHz. 10 to 1 km. Medium frequency. MF. 6. 3,000 kHz. 1,000 to 100 m. High frequency. HF. 7. 3 to 30 MHz. 100 to 10 m. Very high frequency. VHF. 8, 30 to 300 MHz, 10 to 1 M. Ultra high frequency UHF 9, 300 to 3000 MHz, 100 to 10 cm. Super high frequency SHF 10, 3 to 30 GHz, 10 to 1 cm. Extremely high frequency EHF 11, 30 to 300 GHz, 10 to 1 mm. Tremendously high frequency THF 12, 300 to 3000 GHz, 0.1 millimeters. These ITU frequency bands are accepted and used across the globe as the basic definitions of the different regions of the radio frequency spectrum. Radio spectrum bands properties and applications. The radio frequency bands extend over an enormously wide range of frequencies. As such, they have a huge range in the different properties they possess. This means that the different RF bands tend to be used for very different applications. Also, RF designs are undertaken in different ways. Interestingly, above 300 GHz, the absorption of electromagnetic radiation by Earth's atmosphere rises significantly to the point that is virtually opaque. As frequencies rise higher into the near-infrared, it becomes transparent again, giving a window for these and optical electromagnetic radiation. However, within the radio spectrum, each of the bands has different uses for everything from radio communication to broadcasting, satellite links, radar, mobile communications, wireless LANs, and very much more. One of the major differences is the way that the radio signals propagate. The ionosphere and troposphere have effects at different frequencies and by varying degrees. Atmospheric absorption also has effects, particularly at some frequencies. Accordingly, selecting the right portion of the radio spectrum for a given application is crucial for successful deployment of a radio-based system, whether it be for radio communications, mobile communications, data links, radar, remote sensing, and many other applications. Extremely low frequency ELF band. The extremely low frequency ELF band extends from 3 to 30 Hz and has massive wavelengths of between 10,000 km and 10,000 km. Signals at these frequencies are hugely long and are only used for very particular applications. Their main use is for radio communication with submarines, where the very long wavelengths mean that the signals can penetrate well below the surface of the sea. One of the issues with using frequencies of these frequencies is that any traditional form of antenna would be massive, and therefore other techniques are used to launch signals of this nature. Super low frequency SLF band. The SLF portion of the radio spectrum is the next band up, covering 30 to 300 Hz. Again, this is a very low frequency in terms of radio waves, and the wavelength is very long, ranging between 10,000 down to 1,000 km. Again, there are few applications for these frequencies, the main one being communication with submarines. In view of the actual bandwidth of the whole band, signaling rates are very low and messages can take minutes or even hours to send. Ultra low frequency ULF band. The ultra-low frequency band extends from 300 to 3000 Hz, which would be within the audio range if it were an audio signal. The applications for signals in this band are again limited, and while they still include radio communications with submarines, they also include some radio communications for mines and other underground areas. Very low frequency, VLF band. This band within the ITU spectrum band designations extends from 3 to 30 kHz. While the overall bandwidth is still very narrow and the wavelengths are still very long, this sector of the radio spectrum has a few more uses than the lower bands. The band is still used for radio communications for submarines, but there are also some VLF radio navigation aids active, and other applications include heart monitors and SOEM geophysics applications such as ground-penetrating radar. Low-frequency LF band. This ITU band or section of the radio spectrum starts to enter the realm of more traditional radio communications. Extending from 30 to 300 kHz, the frequencies are still very low, but they find more applications. The main activities within this band are some navigation beacons and systems as well as low-frequency accurate beacons that carry time signals. Many radio-controlled clocks use signals on these frequencies. There is also the long-wave broadcast band used within Europe and parts of Asia. Some low-frequency RFID systems use these frequencies, and there are also some LF amateur radio bands. Medium-frequency MF band. The medium-frequency ITU band is far more familiar as it contains the old medium-wave broadcast band. The band extends from 300 kHz up to 3 MHz and apart from containing the medium-wave broadcast band, which is in decline now as a result of superior methods of delivery. It also contains some old maritime communications, again being superseded by satellite communications, amateur radio and a number of other functions. Some beacons were active in this portion of the spectrum as well. The propagation is greatly affected by the ionosphere. It tends to be that of the ground wave by day, but extending much further afield at night as the D region ionization decreases and signals can reach the higher regions including the E and F regions. Global communications can be possible if the times and seasons are chosen carefully. High frequency HF band. The spectrum in the HF portion of the radio spectrum extends from 3 to 30 MHz and is traditionally where long-distance radio communications are effected using the ionosphere to give global possibilities. Being affected by the ionosphere, conditions are very variable being dependent upon many factors including the time of day, season, the state of the sun, especially the number of sunspots and whether there have been any recent solar eruptions, typically coronal mass ejections directed towards the Earth. Many services are found within this portion of the radio spectrum. These include international broadcasting, weather information, point-to-point links, amateur radio, over-the-horizon radio, aeronautical communications, and a number of other services. Although there is much more reliance of satellites, which tend to be more reliable and are not dependent upon the vagaries of the ionosphere, many radio communications services still use the HF bands, especially as a fallback. Very high frequency VHF band. The VHF or very high frequency band within the overall ITU designations for the radio spectrum falls between 30 and 300 MHz and has a wavelength between 10 and 1 meter wavelength. The bands are not as affected by the ionosphere, although at times the lower frequencies are. They can be affected by tropospheric conditions, but in general they are considered to exhibit more of a line of sight form of radio propagation. This portion of the radio spectrum tends to be used for VHF FM broadcasting and newer digital modes of audio broadcasting. SOEM television transmissions occur in some countries as well. Amateur radio bands are present within this portion of the spectrum, and other uses include point-to-point radio communications, aviation and maritime radio communications, etc. Ultra-high frequency UHF band. The UHF band is obviously higher in frequency than the VHF band. It covers 300 to 3000 MHz, and as such, frequency allocations in this band offer a higher bandwidth as a proportion of the overall section of the spectrum. The radio propagation offers more of a line of sight type of link, and this makes it ideal for very many radio applications. UHF is not only used for television broadcasting, but also mobile phone communications, many short-range wireless links including Wi-Fi and other wireless LAN applications. It is also used for a variety of point-to-point radio communications systems as well as for remote sensors, nodes, and the like that could be considered to be part of the Internet of Things, IoT. There are also amateur radio allocations within this band as well. Super high frequency SHF band. Extending from 3 GHz to 30 GHz, this band is within what is often termed the microwave section of the spectrum. The signals at these frequencies have wavelengths of between 10 and 1 centimeter. Signals at these frequencies are being used increasingly for all forms of radio communications including mobile communications, mobile phones, Wi-Fi and wireless LANs and other similar applications. As the bandwidth achievable at these frequencies is high, it enables large amounts of data to be transmitted very quickly. The circuit design for these frequencies can be more challenging and the microwave components are often more expensive. However, with modern design techniques and tools as well as the fact that the cost of microwave components is falling, means that consumer circuits for these frequencies are now achievable. Extremely high frequency EHF band. The EHF band, extending from 30 to 300 GHz, has 10 to 1 mm. These bands are often referred to as the millimeter waves bands. While this is only an informal definition, it has gained almost universal acceptance. With the RF components and design techniques being more challenging than even for the microwave section of the spectrum, costs are high and techniques can be involved. However, as technology pushes further into these areas, the component costs are falling in line with the microwave component costs and microwave design techniques for these frequencies are becoming more achievable. Tremendously high frequency THF band. In view of the exceedingly short wavelengths, between 1 and 0.1 millimeters, and the tremendously high frequencies, these frequencies are at the edge of what can be achieved in terms of current semiconductor technology. Much research is going into the development of these frequencies as they are likely to be used increasingly in the coming years. Understanding the radio spectrum, knowing the ITU and other bands is a great help when using and designing for various radio communications systems, wireless communications systems and the like. Whether it is for voice data or any other form of wireless link, it is helpful to have an understanding of the ITU bands, their properties, and other aspects of their usage.